Hi, welcome to the EEVblog, an electronics engineering video blog of interest to anyone involved in electronics design. I'm your host, Dave Jones. Hi, now this episode might sound a little bit different. It's because I'm not using my regular shotgun video mic because, well, I'm going to mod it for this episode, so I'm using my old shotgun mic, real cheap-ass JCar one that I used to use very early on in the blog, but this is the one I've been using for a long time now. It's a Rode Videomic, designed and built in Australia, here in Sydney. Fantastic. It's one of the best quality video microphones for your camcorder you can get on the market. Professional, semi-professional, whatever. It's awesome quality and it's cheap. It's only like 150 bucks or something. It's an absolute bargain. And there's one real annoying aspect with it for video bloggers like myself who sit in front of the camera all the time. I'm hardly ever behind the camera, not when I got my head on the box anyway. And that is the power LED on it. Something as simple as that. Now on the back here, it's got an on-off switch. There it is, and a high pass filter as well to take out low frequency rumble and stuff like that. If you're using it driving along in a car or something, it's got a filter. And well, anyway, you switch it on and sure enough it goes red at first, but then it goes green to tell you that your battery's good and you don't have to worry about your microphone level at all. And if the LED goes red, then well, you know to change your battery because your mic levels could drop because you don't have headphones on. Well, I don't when I'm actually monitoring this blog. So I'm just hoping that the video is good. And sometimes I sit here in front of the camera and I forgot to switch the damn mic on because I can't see the power LED, or I forget to switch it off afterwards and I drain the battery. It's got a pretty good battery life anyway. It's like 100+ hours or something. I get like 40 episodes or something out of one battery. It's pretty good. But it's just annoying. So I thought I'd mod it to put an LED on the front so that I could see it. There it is. I've already done the mod, but we'll actually see that. So I've added that little green LED on the front there. Very simple mod, but anyway, I thought I'd take it apart and just show you the mod. So here goes. And if you're after a video mic like this, I highly recommend it for your camcorder. It's got a standard 3.5mm attachment. Best quality on the market, really hard to beat. And it's got this lovely rubber O-ring shock mount system like this. There's actually, I think there's just a brand new one on the market. Not sure if it replaces this, but it's the Videomic Pro. So check that one out. It's sort of like a shorter type thing, because this thing can look pretty damn intimidating when I've got it sitting on top of my tiny little camcorder, which is my Sanyo camcorder, which is only about that long. So it looks really out of proportion to my camera. But hey, when's that ever been a problem, right? Anyway, here we go. And I've taken it apart. It required a fair bit of effort. There's a few clips and things you've got to undo, and there's a sticker on the back here which has where the switch actually protrudes, and that's actually stuck on to the back half, to the other half of the unit here. So you can actually just sort of hinge it off while it's still attached, but I just decided to unstick that from the other side just so it comes permanently apart. And if you're wondering what's inside one of these shotgun mics, well, here it is. No surprises, just a discrete transistor preamp circuit. You don't need much at all. Going off to the microphone insert, which is actually just in the back here. This tube up here literally is just a tube. I don't know if you can don't know if we can actually get the camera down in there, but the element is actually right down this end of the tube, and the tube just literally is a hollow tube, or it is actually designed with slots inside like that. So I don't know the acoustic pattern of how all that works. You'd have to really be an acoustics expert to understand the lobe patterns and all that sort of stuff. But anyway, there's not much in a basic shotgun mic at all. It does have a 3-stage sort of like a filter on the front like that, so it's that actually wedges that actually slides in the front there, and of course the windshield just pops over the whole thing. And here's our preamp board here, and what we're interested in is the LED, which is under this light pipe here, which actually bends the LEDs, the surface mount PLCC package on the board, and these light pipes just trap the light inside and then bend them around and focus them, and they shine out the end here. That's how you can get an LED on the end of your panel without actually having to bend it up off your board and mount it on the back panel and wire it across. These are very popular, these light pipes. They come in all sorts of shapes and sizes, and as you can see, it just actually clips into 2 holes on the board, and bingo, there is our PLCC package LED. It's a standard 4-pin PLCC package. It's got red and green because it's got this device has multiple colors, and to show you the state of the battery, green is full and red is low battery. Now if we plug our battery in here, you'll see that there's physically two dies inside there. The top one is the red one. If you see that little die inside the device, that top one there is the red, and the bottom one is the green. Now the pinouts for these, if you actually look through, you'll be able to see the bonding under a microscope. You'll be able to see the bonding wires go across from the internal die in there over to the external pad. So the bottom one is the green one and the top one's the red. So the 2 pads on the bottom will be the green. So, and the 2 pads on the top will be for the red. They're 2 separate LEDs in the one package. And clearly these two surface mount resistors here are the lead dropper resistors, the top one for the red and the bottom one for the green. But I'll just measure that with the multimeter just to make sure there's continuity there. I think I can see it. There you go, you can see the little trace there, even on this camera. So I'm pretty darn sure they're the dropper resistors. So what we need to do is attach our LED with its own dropper resistor from here across to here. So because you never wire LEDs directly in parallel, because they're a non-linear element and they'll have different voltage drops depending on which changes with the current, and if they're not matched up, one LED can hog all the current and it takes all the it'll appear bright, and the other one might appear dull or even completely off. So that's why it should have its own dropper resistor, so that you adequately share the current between the 2 LEDs. So I'm wiring these LEDs in parallel but with their own dropper resistor. Now what I'm going to do is measure that dropper resistor value in there and also the voltage across it, so I will know how much current each LED, or the green LED, is drawing. I don't really care about the red, I just care about the green. So here is where I've got to hold it. Here's a tricky situation. I've got to sort of use a third hand holding the battery at the same time as probing 2 points, holding the battery and watch the display at the same time. So here's where your auto hold function on something like a fluke meter really comes in handy. So let's give that a go, and I don't even have to watch the meter. I can just concentrate on holding that battery in place with one finger and probing it with another. Let's get the probes around the right way just so we don't end up with a negative sign, shall we? Not that it matters. So I'll put my probe on there and bingo, 4.534 volts. And if we measure the resistance, we'll do that with the power turned off. It's a 1K dropper resistor, and the resistor above it is, yeah, a 1K as well. So 4.5 volts across a 1K resistor, that means that LED is consuming 4.5 milliamps of current, or they're driving it with 4.5 milliamps, which is rather high for a 9-volt battery, but the battery life on this thing is quite decent anyway. So here's a basic DaveCAD drawing of what we've got here. We've got our 4-pin PLCC dual red-green diode here, red up the top, green down the bottom. We've got 2 dropper resistors and some switch over here, a transistor switch on this side over here to actually switch each one off and on. And we're just going to put another green LED here in parallel with it and with its own dropper resistor. As I said, we don't put them directly in parallel with that. And I've measured these at 1k each with 4.5 volts drop across it. That means there's 4.5 milliamps flowing through the LED like that. For it, you fly to the moon on that amount. So this one, I think I'll up it to maybe 2k2 or something like that. So I only get a tiny little 2 milliamps flowing through the LED. And that should be more than good enough. The little LED, 3mm LED I plan on using, it should work at 2 milliamps. So my goal is to stick a 3mm LED on the front here, which means I've got to drill a hole, a 3mm hole, through this case here. And is there enough room on the other side? Well, if you open it up and you look in here, there's actually a wall. There's the battery. There's a wall there that actually holds the battery in place. But there's enough room, I think, to actually put the LED in there and bend the leads immediately at right 90 degrees and take them behind this wall here, like, well, that. They'll go behind the wall, it'll bend at 90 degrees, and I should be able to wire up through here onto my LED. Let's give it a go. There you go. You can never trust 3mm LEDs these days. 3.05mm, so I think I'll use a 3.2mm drill bit for that. Should work a treat. Right about there ought to do it. And that's just about perfect. I like it. And there you go. I've installed my LED with some heat shrink on the back of the wires, bent it over there, and I put my 2K2 in series here in the lead, and I've heat shrunk that, and let's turn it on and give it a go. Ta-da! There we go. Lights up green. No problems at all. And we're only wasting about an extra 2 milliamps from the battery to light up the LED on the front. Beauty. And when you're doing mods like this, sometimes you can't actually solder directly onto the point you want to. I couldn't solder directly onto the LED because it was under this light pipe. So I had to just trace out where the track went. And I found the point over here on that SOT23 package. So I used that one and also the top of the dropper resistor in there. There's one novel construction aspect to this. There's two screws which hold the base of, well, actually screw into the base of the shock mount unit, and what they do is they actually use these little brass inserts here, and they actually slide down in there and line up with the hole in the bottom of the case, and it's really quite a nice little design concept. So they just slide into these little recesses like that, and they line up, and then these come over and allow the screw to go through the shock mount unit, which this attaches to, into that brass insert. And it all snapped back together rather nicely, and you can see one of the wires up there, and it's quite neat. It just tucks in there like that, and let's try it out. Put it in. I put it in the right way. Ta-da! Green and green. Too easy. Check it out. Made in Australia. You bloody ripper.